All right. So we don't have folks viewing yet, but this will be recorded, so we can post a video of it. Since we have a long agenda today, I'd like to go ahead and get started. And we're going to start our demo with some items from Adam, specifically working on layered images. I will share a link, one second, in our IRC chat, which is Fedora-meeting, just in case anybody wants to follow along with the agenda. And there are links in there for things that you might be interested in digging into as we go. But Adam, we'll go ahead and get started if you want to take over.
Okay, thanks. Let me share on my browser windows that I have the font size nice and big on. You ready to see that and read it? Good.
Yeah.
Okay. So one of the changes that is currently being worked on, and this actually predates the Fedora 24 cycle, but just kind of as things have changed and things have shifted, we have continued to work on it. But one of the things that has been hammered down is, oh goodness, that is, let me zoom out here. The schematic of kind of the overview of the actual design of the layered image build service has been hammered out. A lot of the components of this were kind of in flight. We were waiting on some upstream components to stabilize and some of that to kind of settle down. And now that it has, this is kind of the plan that we're going to be going with. And for Fedora developers and packagers who want to work on creating Docker layered images out of their packages or in addition to their packages, will be able to do so in the Fedora 24 timeframe, and it will be a very similar workflow to the way that it works now. So what you would do today is do like a fed package build, and you would get an RPM, and then what we'll have is fed package image build in the future. The exact syntax of that command is still undecided upon, but the workflow itself will be very similar, and very much how we have the ability to do a fed package clone for the Git repository of containing the RPM spec file. We will have a very similar workflow for the Git repository containing a Docker file. Then that build, once you kick it off with fed package, will be farmed out to Koji. Koji will actually talk to the OpenShift build service, which is kind of the driver behind the layered image build service. That will communicate with our registry, which is going to be driven by Pulp. For those familiar with Pulp, Pulp is an upstream content registry or content repository management system, open source, and we will be bringing that into Fedora space as well. Pulp has an endpoint called Crane. Crane allows Pulp to act as a Docker registry, so this will allow us to very quickly iterate over things in terms of people who want to work on layered images and have them available to test and develop upon. So as soon as the build goes in, they can point to a specific registry endpoint with their Docker daemon and pull that in, which is kind of the endpoint for the Fedora contributors. The big piece of this that I think is potentially new to some people or don't have a lot of background is going to be the OpenShift, and I'm going to talk about that in a moment as well, because that's another change that we're trying to bring in. But up here on the right is just kind of the magical future. We have a lot of plans around allowing continuous integration and automated testing so that we can do automated releases. Another thing that's in scope here is automatic rebuilds. So one of the concerns with Docker layered images is you have at the start of your Docker file a from clause, and that from clause dictates what image your new image will be built on top of, where its starting point is, and we consider that the base image. So we will effectively have a system in place that is going to track base images. So in the event there is an update, whether it be bug fix or security or otherwise, the system will have a mapping and will detect that your layered image depends on something that has been updated, and it will then automatically rebuild your image so that it can inherit those new changes and get the updates as necessary. And that's kind of to address, hopefully to address the security concerns around some of these things, as well as just to fast track bug fixes that the Fedora users and contributors kind of have come to expect. So moving on, the OpenShift piece. So OpenShift origin, for those not familiar, is so OpenShift is a platform as a service. It is an open source platform service developed by Red Hat, and the current iteration of it is considered architecture v3, and it was a complete rewrite from the ground up. And one of the big things that was done in the v3 rewrite is that it was based on Docker and Kubernetes. Kubernetes being originally open source by Google, Docker by Docker Incorporated, previously .cloud. And then also a piece of the puzzle is going to be Project Atomic, which for those familiar with Fedora Atomic, we'll kind of see how all of this fits in. It introduces this ability to kind of manage containers as higher level abstractions, and we wanted to bring it into Fedora as a change. Number one, to have it available to the Fedora community for the users who want to use and run it, and then also as part of the OpenShift, as part of the OpenShift build service that we will be basing the Docker layered image build work in Fedora on. So that's where a lot of that is going to come in. I have a very quick demo of it running. I need to switch browser I'm sharing that I want to just kind of quickly walk through. This is OpenShift Origin running on Fedora, just to kind of show proof of concept that it does work, and that we're not just showing wiki pages and hand waving. So I have OpenShift Origin running here, and I have this demo project. And inside this demo project, I have deployed an application. In vocabulary terms, it has different nomenclature, but it's effectively an application. And I'm sending this browser over SSH X11 forwarding, so you'll see a server interrupted because my network connection is not the best. But if we click here and we attempt to go and view this application, the web app, will load. Yeah, the web connection is not the best. Okay, so it'll load, and we have a page here, and we're serving content, and inside here we can kind of see a topology of our application, and you can browse all kinds of things. There's deployments. The platform as a service component has like builds and this idea of an image stream, which lets you define all sorts of things about how you consume containers and images. And the OpenShift documentation has much more on that. We will be working with the upstream OpenShift team to continue to keep Fedora as a entry point that can be deployed. And for the first run, you will be able to use the actual official upstream OpenShift installer to actually install OpenShift Origin from the official Fedora repositories the day that we release Fedora 24. It is in Rawhide now. You can test it there. There's currently a SE-Link policy bug that I will warn you of. But that is it in a nutshell. I will hand it back over. I know we've got a lot of stuff to go through.
Yeah, we do. Thanks, Adam. So I am in hash Fedora-meeting. Folks who are demoing should jump in there as well. So since we're doing so many things in this demo, if you have questions, it would be helpful to throw them in there. If we have time at the end, then we can talk through things with as much time as we've got. But I'll go ahead and hand it off to Ratnadeep to show some front-end changes to AutoCloud.
Can you hear me?
Yep.
Yep. So I'll start by sharing my screen. So can you see my screen?
Yeah, we can.
So here's AutoCloud already deployed in production. If you go to the job details page, so it lists the jobs being like for testing Fedora cloud images. So we see the status of the jobs. Some are queued, some are failed, and some are in success. And in the last sprint, there was discussion to actually add some more fields for each job. So the fields being like telling whether the job is for atomic or base image, or which architecture does it belong to, and like for which Fedora release is it for. So, and on top of that feature request, there's another request to actually add filters for the new fields. So I made these changes in the sprint, and so here's AutoCloud running in my double box. So here you can see that in the job listing we have new fields where it says our family. We could find a better name for this column, but it says that whether it belongs to atomic or base, and the architecture of the jobs of the images, and the release and their release and status was there from earlier. So the new fields have been added, and here is the basic filter for this for all the fields basically. So we can filter by family. Say we want to see all the base jobs for base images. So we filter and we see it's filtered accordingly. So we might want to filter by architecture. So I choose x86-64, hit filter again, and yes, it's only showing that, and maybe I want to see only Fedora 22 related builds. Here it goes, and status currently all the jobs in my devel instance are in queue because I have not run tests on them. But yes, this is like adding. We have added new columns for each new fields for each job, and like we have added basic filtering on top of that. Yeah, this completes my demo.
So swift, so timely. Thank you, Ratnadeep. So again, if you have questions about that or any requests or feedback on the changes as they stand now, then feel free to raise them in IRC. And like I said, we'll talk more at the end if we have time. So if you're ready, Jay, I'd like to cut over to your demo next.
Sure. How's this look?
Looks good.
Okay. Text is okay? You can read it?
Yep.
So I've been working on having Koji provide signed repositories of signed RPM content. This has a couple of different applications for building images and for building or providing Bodhi updates and for doing composes and installation media.
Yeah, you got muted somehow.
How do I unmute?
You are unmuted now. We can hear you again.
All right. I didn't do it. Maybe it's the typing is auto-muting me. I don't know how to stop that. But here's the contents of 2 tags. And then
I'm muted, right?
you guys hear me okay?
It's in and out. You may have to try to wait until you're done typing to talk, unfortunately.
That'll be fun. Okay. Okay, so here's the contents of 2 tags. And then you can see one inherits from the other. And if I try to create a signed repository it's going to fail. And that's intentional right now because these guys here are unsigned. If you look in the output above, you can see that the pigeon build in here is in the not candidate tag, which comes earlier in the inheritance. So if I do the same thing again with no inherit, it should work. And away it goes. We're going okay? I'm not going to watch that. So there is a way now to allow unsigned builds into these results if you wanted to. That's what the allow unsigned command does. I can look at past results because this takes like, all of these commands take like maybe 10 to 15 seconds to complete. And I just don't have that kind of time. So if we look at the results from one of those previous runs, you can see here's a whole bunch of RPMs in here. If we look at the package list in there, whoops, you can see at the upper portion here, you can see signed repository paths, and that's indicated by these little GPG key IDs in the mix. But you can see that the pigeon pieces and the pigeon pieces down here are using the normal unsigned packages. So that's what allow unsigned does. That's useful for like rawhide. And then I have another one. Yeah, I gotta type. I also have skip unsigned, which rather than including unsigned RPMs, it will just skip them entirely. So they won't be included in the repo at all. So if I look at previous results there, you can see that in here the pigeon builds are not included, or the pigeon packages are not included at all. They just got skipped. Let me show the tags once more because I want to show the feature next. And this lets a user generate a signed repo based on a past event, which basically lets you go through recorded history and generate a repo from the way the tag was in the past. So give me a moment to type out some commands and then I'll explain them. Okay. So again, looking in here, you can see that, actually, let me show you the history here. Just let me take a tail of that. A while back on December 4th, on December 8th, I pulled out RubyGem Puma and RubyGem Psych from the candidate tag, and if you look up above, you can see those guys are missing. Up here, they're not included. Using the list history command, I can get event IDs, they're called, and you can pass that into a new option to the spin or the signed repo command. So if I do something like this, that's going to generate a signed repo based on information in the tag back on December 7th. So looking at older, I'm going to look at older results here. In these results here, there's the Psych and Puma there, just to prove that I'm not lying. This is the most repo. The 1214 is the most repo or most recent repo generated. Make sense? Last feature I'm going to show is delta RPMs. Let me show what's going to be included here. So here's the contents of two older directories of RPMs. They just have, I'm just showing you the contents of them. They got a pile of RPMs in there. Some of them are older. than is what is currently. Some of them are older than what is currently tagged in the tags that I showed before. So let me do the let me run this command, and then I'll show you the results. So in here, we pass in -- delta RPMs twice, one for each repo, and you can stack this up as often as you want, and it will generate delta RPMs for each set. So this repo's ID is going to be 1215, which I can show later if people don't believe me. Results of that command look like this. Oops. So in these results, there's a DRPM subdirectory, which is kind of which is what create repo normally does. And looking in the content, I kind of jumped the gun there. You can see that bcrypt, event machine, nokogiri, and thin. There are delta RPMs, and those are the ones from the earlier folders that have those are the earlier RPM that contain those folders. So we do the same thing again after blabbing. And that's it for the demo. So just sorry, I know I just heard myself on mute there. Thank you, Amanda. This is what I've got so far. Allow unsigned, delta RPMs, creating signed repos by event. Multi-lib's a lie. That's what I'm working on right now. That doesn't actually work, but it's coming. No inherit, and skipping unsigned packages. And that's it.
Cool. Thank you, Jay.
Mm-hmm.
All right. So next up is Ralph, if you're ready to run us through PDC.
Sure, I can do that.
Perfect.
Screen share.
And Ralph, I know that PDC, I think this is the first time we'll be seeing it in this audience. So if you could give just a little bit of background on that too. I'm pretty sure we haven't done that yet.
Sure, sure. So we have a Fedora change file for it. So you can go and read a lot more on the wiki page here for changes/PDC. But the gist of it is that we, in RailEng, generally produce a whole bunch of artifacts, composes and images, and all of the components that go into that. But we don't have an easy way to be able to query a database to figure out what we have produced and then what went into those artifacts that we produced. And we also don't have a database that we can query to figure out what we're going to be producing and what should go into those artifacts. It's two different problems that PDC tries to solve. It's a web app. It's a web service in a database that is particularly passive, right? It doesn't actually do any of the production of the artifacts itself. It's just a store to keep track of what happened and what we expect to happen. So luckily, other people, other Red Hatters, have already built the web app and service itself. It's called PDC, Product Definition Center. But the hard part for us then is hooking it up with all of our existing processes to populate it with data to make it actually useful. And this is detailed in the change document, but we thought about two ways of doing this. One would be to go into all of our RailEng scripts and modifying them to update PDC with information about their output when they finish. But we thought that would be problematic because we'd have to modify all these different tools and spend a whole bunch of effort kind of tracking down every corner where that needs to happen. And so instead, I've started writing this tool called PDC Updater, which is going to be a daemon that sits in our infrastructure listening to our message bus to fed message and then responds to all the events across our infrastructure about what's actually happening, and then in turn updates PDC with a kind of persistent data nugget about all those events. So we have a development environment, a develop instance for PDC stood up here in the Fedora Infra Cloud. This isn't going to be permanent, so you can look at it, but don't write any code that uses it.
Hey, Ralph.
Yeah.
I'm going to interrupt you because I think you might be trying to share your screen, but I don't think we're getting it.
Oh, really?
Yeah. Could you try one more time?
Sure. What were you getting?
Jay's face.
Jay's face. How about now? Are you getting it now?
No, I see it on yours. Let me try one thing on my side.
Let me try.
I'm seeing Ralph just fine.
screen. I share my entire screen. How about now? Can you see this? I'm just looking at the PDC app.
I can see it.
You can see it? Anybody else?
So people on IRC are reporting that you're sharing the screen, but for whatever reason, J is of the small, like, cubes at the bottom of the screen. J is the large picture.
Oh, so
Don't let it go to your head, Jay. Let's see. Every time Google does something interesting. Wonder what happens if I do this. Well, now it's just me. I think that did it.
well, can you see my screen now?
Yeah.
All good? Should I proceed?
Yeah, go ahead. Sorry for the interruption.
No, that's all good. So we have a dev instance set up, but it's not stable. We nuke the database about once a day and rebuild it, and I'll get into the tools that we use to do that in a minute, but you can kind of click through here and look at some of the stuff that we have in place right now. So under releases, you see we have a couple Fedora releases, Rawhide is here, and then we have updates releases for the previous releases. Under composes, you can see we've imported a handful of composes that Dennis has been working on for his change. And then the most useful thing, I think, is this API tab, which is a little self-documenting JSON API. And so you can click on different things to find out how you might query these different endpoints with a program or a script. So here, just to show, click on composes, and then there's documentation about if you want to list the composes, or if you want to retrieve a particular compose, or if you want to update or bulk update things. You can read the docs on how to do that. So that's the dev instance. Let me see, if I switch over here to a terminal, can you see this? Waiting for confirmation.
Yes, we can.
Great, cool. So in two split panes here, on the top, what is running is the daemon that we'll leave running in the background in our infrastructure kind of all the time. And that's an instance of the Fed Message Hub with this PDC updater plugin installed with it. And you can see it's flipping out right now. I don't know if you can see that rush by, but a bunch of things got tagged into different tags in the ARM secondary Arch Koji instance. And so currently this tool doesn't do anything with the secondary Arch stuff, it just ignores it. And so all of those got skipped. And so I'll just let that run while I talk about the other tools. And if we're lucky, something interesting will happen and we can see stuff go by in the logs. But so that updates PDC with information about stuff as it happens, but we also need to be able to go back and get the previous information about previous composes and previous artifacts and components. And so for that, let's see, here it is. There's a PDC updater initialize command that will go through all the PDC updater plugins we have and ask them to query their data sources for all of the historical information, and then it just imports all of that into PDC. And I won't run that for the demo because it takes like 18 hours to run. So you just let it go once, and then we never run it again. Next to that, really similar, is this PDC updater audit command that does the same kind of thing at the outset in that it queries all of the original data sources and gets a list of everything that has been produced from Koji, from the composes, from PackageDB. It gets all the branches that should exist in Git. And then it, on the other hand, queries PDC to figure out what has been imported, and then it compares those two lists, and it prints out a report about what's missing from those two different sources. If we edit this configuration file, you can see that there's these handlers that define all the functionality for what should be done. So running audit also takes a really long time. But if I comment out some of the slower running handlers and we just deal with composes, it's relatively quickly we can run that command and see what it does. So it's going through here. It's querying Koji packages to find these new composes that are pumped out by Punji Koji, by Punji 4. Waiting, waiting. And then it prints out a summary that is kind of uninteresting. It just shows the one handler that it did run, an X for it's OK, and then if there were any problems in details after that, it would print and say, PDC is missing this new compose that must have failed at some point. The whole point of this is we can run this audit command in a cron job every couple hours, and then have it email us reports that something has gone haywire here. In the event that it does find a problem and we need to be able to repair the data in PDC, there is one more command to PDC. There's initialize, audit, and then there's also a retry, which takes the message ID of a fed message, and so you can ask it to query and pull down a single message and then replay that in the PDC, in the local PDC updater instance. So I'll switch here and go to, sorry, I'm going backwards here. Let me re-enable those plugins that I disabled. So we have all of them in place now. We've got a retry command, and we'll get a fresh message ID. Go down here, oh, excuse me, and look at data grepper, and say we'll pick one. How about this EPL7 branch for Ola? Get the message ID here, paste it in, and fingers crossed, it prints out that the compose handler couldn't handle that message because it's not a compose. But if we look further up, the new branch handler did handle it, and then it checked for a global component that didn't exist, so it created it. And then after it created the global component, it then created the release component, which is, this is all PDC terminology about the different scopes of objects that should exist. So that's it for my demo. If there's any questions, I can try and answer them.
Very cool. All right, thank you, Ralph. So, Dennis, that leaves you to give us a preview of Punji.
Let me try and share my screen. Start with demo. I'm gonna have to change share screen in a little bit because I don't think I need to share.
You still there, Dennis? Well, good thing we saved him for last. Let me see if we can retrieve him. Hold on.
I've got one more, remember? If I need to step in.
Yeah, actually, you know what? Why don't you go ahead? Let me see if I can. Can you just share your screen while he's still attempting to share?
Yeah.
Okay. We must have dropped him.
Okay. So two other things that happened this cycle that are public-facing that we wanted to kind of mention and highlight is in the Atomic 2 week, for those who tuned in last time and remember, we now have this Atomic 2 week release cycle. We needed a way to mark bad builds manually, mark good builds manually, and block the release wholesale manually if necessary. We needed kind of a by-hand way to do this because in the automated system, there are certain scenarios that can come up where a build may or may not be marked good or bad and isn't actually bad. Now there is a note in here that we plan to replace this with a more permanent solution around PDC at a later date, which I'm super excited about, and I hope everybody else on the call is as excited about Ralph's demo just now. But there's 3 JSON files, and we chose to use Figure because it gives us the access permissions so that we can allow different people within the release engineering group as well as different folks within the Project Atomic teams to actually mark these things good or bad. The 2 week release script will check them at the time that it runs, so that we know not to accidentally release things that we shouldn't be, or to make sure to release things that we should be. Another thing that we did is we now have a contribution guide for the Fedora release engineering team. We have a contribution guide for how to contribute directly to release engineering, to our Figure RELng Git repository, as well as a developer workflow, recommended topic branch workflow. There's upstream documentation for Git for those who are new, and then also a helper shell function for users of Bash or something compatible to be able to kind of quickly help as they work through that workflow. And then we have a list of tools that release engineering uses. Release engineering is actively involved in the upstreams of a handful of utilities, and then there's a number more that we tangentially are involved with because we are consumers of them, and we will, in the event we find issues, we will absolutely push upstream, but they're not tools that we actively as a group participate in the upstream ongoing development of. So information about those is listed here, as well as links to them and how to just generally get involved with Fedora release engineering development as a whole, as well as the tools that we use. And this is part of an ongoing effort to improve documentation in the Fedora release engineering group so that we can better help newer interested contributors to join. And that was all I had on that topic. Is Dennis back?
Dennis, let's try this again. Oh, come on.
I think we lost him again.
All right, give me just a minute. We'll try it one more time, and if we can't get him to actually be able to share, then we'll go ahead and drop, and we'll try to figure out how to record something and share it out later, maybe.
I keep dropping out of the meeting.
All right, let's try it one more time, Dennis. If you get hung up again, then we'll try to record something later and share it out.
Okay.
Okay.
All right. I'm going to share my screen. Can everyone see okay?
Can you bigify it just a little bit?
Magnify it how?
Increase your font size. Perfect.
Did we lose Dennis again? All right. Okay, so we are going to go ahead and wrap up then, because clearly this was not meant to be. I will work with Dennis to get something recorded. Basically, Dennis is going to run through a demo of Punji 4 doing running a compose and show us the output of that. Likewise, there is a change filed for this deployment. It's also lined up for F24. So if you are interested in reviewing that, there's a link on the Taiga wiki page that I shared in IRC, and it's also in the meeting invite. So feel free to take a read over. Like I said, if we are able to get something recorded, I'll share that out as well. If there are other questions, then I think most folks know where to find us, but most everybody on this demo hangs out in #Fedora-Relinge. We'll be doing another demo in about a month. Even with the break in the middle, I'm sure we'll still have some things to run through for you guys. And January will be a busy month for us because we'll be trying to wrap up as many of these changes as we can. So thanks everybody who joined, and we'll see you again for the next one of these in January.